Let's look at how to play around with complex numbers. Now, first of all, we have to understand when are two complex numbers equal. So, a plus ib, and we have, let's say, c plus id. Now, when can we say that they are equal? Yes, let's actually arrive at that solution by doing some operations on this. So let's bring in real numbers together. So a minus c and id minus ib. So a minus c is equal to I, let's take it out common, d minus b. Now let's square them up. A minus c square is equal to I square d minus b square. Now I square is minus 1, right? So I is equal to square root of minus 1. I square would be what? When we square this, the root will disappear, so we are left with minus 1. Similarly, I cube would be I square times I, which is equal to I square is minus 1 times square root of minus 1. So which means minus 1 times I, which is minus I. I to the power of 4 would be what? I square times I square. I square is minus 1 times minus 1, which is 1. So you can keep taking this forward and arrive at these results. So here I square is what? Minus 1. D minus B square. A minus C square. Now let's bring this to this side. A minus C square plus D minus B square equal to 0. Now this is interesting. The sum of these two is equal to 0. That means what? Even if one of them is a number other than 0, this cannot be 0. So this is possible only if a minus c square equal to 0 and d minus b square equal to 0. They both have to be 0 for their sum to be. So now let's remove the squares. So take a square root on both the sides. So a minus c equal to 0, d minus b equal to 0. A is equal to c, d is equal to b. So what have we arrived at? We have arrived at the fact that these two will be equal. These two complex numbers will be equal only if A is equal to C and B is equal to D. Right? A is equal to C, D is equal to D. So remember this. Okay. Now let's look at some arithmetic operations. Let's look at addition. Okay, let's take A plus IB plus C plus ID. We have to add these two complex numbers. So what do? We add the real numbers together and the imaginary numbers together. So A plus C plus C, no not C, IB plus ID, which becomes A plus C plus I B plus D. Now subtraction is nothing but C plus ID. So here instead of adding numbers, we are subtracting the numbers, real numbers together and imaginary numbers together. So A minus C or plus IB plus ID. No, minus ID, which means A minus C plus I B minus D. Now we may end up with situations where it's addition subtractions are mixed up. For example, we might have A minus IB right? Minus C minus I D. Just follow the normal rules of arithmetic. So let's say open up the brackets. So minus into minus plus C, minus into minus plus ID. Now group them together. So A plus C plus I is common, minus B plus D. Now if you don't want minus to be the first term, just exchange these places. So A plus C plus I D minus B. Okay, let's come to multiplication. So A plus IB times C plus ID. Straightforward distributive property. Just distribute. A times C plus AID plus CIB plus I square BD. So AC plus I is common, AD plus CB plus, now I square is minus 1. So let's take it as minus. Yes. Your normal, identities do work here as well, but slightly differently. But the process to arrive at those results are same. Say for example, we have A plus IB square. The process remains same. A square plus 2AIB plus IB square. So I square B square. The only thing is when we simplify it, this becomes I 2AB. Now I square is minus, so minus B square. Similarly, A minus IB square will become A square minus 2AIB plus I square B square. Now this on simplification becomes A square minus I 2AB minus B square. Similarly, let's take a cube. So A plus IB cube. This would be what? A cube plus 3A square IB plus 3AIB square plus I cube B cube. Okay, so this becomes A cube plus I 3A square B plus 3A square I square B square. I cube is what? I cube is I square times I. I square is minus 1. So this plus becomes minus and we are left with I. B cube. So on further simplification, it becomes A cube plus, we have a I here, we have a I here, we have a I here, but this is I square. So this I square can also disappear and this become minus. Yes. So we can bring this to this side. So minus 3A square B square plus I, and we have 3A square B minus B cube. A cube minus, so A square we can take it out. So A square A minus 3B square plus I, B is common. So B we take it out. 3A square minus B. So as you notice, just follow what you have been doing it. The only thing that additionally you have to take care of is when you end up with I square, I cube, right? Then you have to be careful and the grouping has to be done accordingly. Okay, now let's look at A plus IB times A minus IB. But by the way, these two are called conjugate pairs of complex numbers. The only difference between these two is plus and minus. One is plus, one is minus. Everything else is the same. Okay, so now how do we solve this? Remember, this is like your A plus B times A minus B. So straightforward, we can say A square minus IB square. But then we have to simplify it. Minus I square B square A square plus B square. Yes. Okay, so that is multiplication. Now let's look at division. Let's say we want to divide A plus IB divided by C plus ID. So what do? This technique you have already used. So what we do is we rationalize the denominator, right? So A plus IB by C plus ID, we multiply this by the conjugate of the denominator. So C minus ID. C minus ID. And now we just keep simplifying it. So AC IBC minus AID minus I square BD divided by C square plus IDC minus ICD minus I square D square. Now if you notice, this and this gets cancelled. So we have AC minus IBC plus AD. Because of this I square, this becomes plus divided by C square, and because of this I square, this becomes plus. Don't try to remember this as a formula, because you will end up with a lot more formulas, so you can't really remember all of them. Now we can actually organize it in such a way that it looks in the form of A plus IB. Okay, so let's bring in BD to this side. So BD minus IBC plus AD, and let's write this separately for both. So understand the process. Don't try to remember it as a formula. Now one thing you might have noticed is that when we multiply conjugate pairs, you end up with the imaginary number disappearing. So that is as well as, this was a very brief introduction. If you want to go into more details, please go to the playlist on complex numbers. That's enough for now. Bye.